Hi student, my name is Professor Prakash Vasanthar, author Engineering Mathematics first, second and third for B first year, second year and third year for all branches. Mathematics part first and second for class 12. Today again we solve some problem from exercise 1.1. Name of unit is differentiation. Mathematics part second for class 12. Today we solve problem number 13. Problem number 13. In this problem, we find dy by dx. That is again differentiate the given functions with respect to x. To find dy by dx, if y is equals to e to the power log of in bracket log x whole square minus log x square minus log x square. This is the given function, that is y is equals to e to the power log in bracket log x whole square minus log x square. And we find here the derivative of these functions, that is differentiate these functions with respect to x. So first we write here the given function. First we write here given function. For simplifications here, taking log both sides, taking log both sides, taking log both sides. Therefore, log of y, that is here log y is equals to log of right hand side function, and here right hand side function is e to the power log of log x whole square minus log x square. Write these functions here. Therefore here log y as it is equals to, use here log m raised to n log m, that is log of log x whole square minus log x square into log e, but log e is equals to 1. Here on right hand side we use the formula log m to the power n log m. Similarly here log e to the power log in bracket log x whole square minus log x square. This can be written as log in bracket log x whole square minus log x square into log e into log e. Therefore here log y as it is, which is equals to, here log e is equals to 1. We know that the logarithmic rule, the value of log e is 1. So 1 into this function. So we get here log of in bracket log x whole square minus log x square. That is here we simplify the given functions with the help of the logarithm. Then here differentiate both sides with respect to x. Differentiate both sides with respect to x. Therefore here ddx of log y, ddx of log y. So right here log y, ddx of log y is equals to ddx of log in bracket log x whole square minus log x square. So write this here. Therefore here ddx of log y. When now that the formula ddx of log fx, 1 by fx into f dash of x. Similarly here 1 by y, 1 by y into dy by dx, dy by dx, which is equals to. Again we find here ddx of log x whole square minus log x square. So we write here ddx of log x whole square minus log x square. Use here formula ddx of log fx, 1 by fx into f dash of x. So 1 by fx, and here fx is this function. Into ddx of log x whole square minus log x square. Therefore, here 1 by y into dy by dx is equals to 1 upon log x whole square minus log x square. Up to this step as it is, we write this here. Then we use here the subtraction rule. ddx of u minus v, du by dx minus dv by dx. Therefore, ddx of log x square, ddx of log x square. Use here formula ddx of fx to the power n, fx to the power n minus 1 into f dash of x. So here 2 into log x into ddx of log x into ddx of log x, that is 1 by x. Again we repeat this. Here ddx of log x whole square. Use here formula ddx of fx to the power n, fx to the power n minus 1 into f dash of x. And fx is replaced by this log x. Therefore, here this 2 log x to the power 2 minus 1, that is 1. So log x into ddx of log x, 1 by x minus ddx of log x square. So first we use here log m raised to n log m. So right here 2 into log x, and ddx of log x is 1 by x. ddx of log x is 1 by x. Therefore, here dy by dx, which is equals to dy by dx is equals to y. Y into this function, so right here y into first we write here the numerator 1 into these functions. From this 2 by x take common, and in bracket log x minus 1. So right here 2 by x take common, in bracket log x minus 1. So right log x minus 1 upon this log x whole square minus log x square as it is. So write this functions here. Therefore, here dy by dx is equals to y, but y is given function. Y is this given function. So we write here y is equals to e to the power log x whole square minus log x square. So write this here y is equals to this function. Then here 2 into log x minus 1, 2 into this log x minus 1, log x minus 1 upon this x into this denominator. So write x in bracket log x whole square minus log x square. And this is the required derivative of the function, and a function is y is equals to e to the power log of log x square minus log x square. But find here the derivative of these functions, and derivative is that is dy by dx is equals to e to the power log in bracket log x whole square minus log x square 2 in bracket log x minus 1 x in bracket log x whole square minus log x square. That is in this way. But find the derivative of problem number 13 in exercise 1.1. Unit is differentiation from mathematics part second for class 12. So dear student, if you like my video, please subscribe my channel and press on bell icon. Next problem, that is problem number 14. Problem number 14. Again in this problem, we find dy by dx. Find dy by dx if y is equals to sine under root sine root x sine root x. Now find the derivative of these functions. That is find dy by dx. Find dy by dx if y is equals to sine under root sine root x. So again, first we write here the given function is the given functions. And we find the derivative of these functions, that differentiate these functions with respect to dx and find out dy by dx. So here we are differentiate both sides, differentiate both sides with respect to x. Therefore, ddx of y, right here dy by dx, dy by dx, which is equals to ddx of sine under root sine root x, sine under root sine root x. So write this here. Therefore, dy by dx, which is equals. Find out here ddx of sine under root sine root x. Here we use the formula ddx of sine fx cos fx into f dash of x. ddx of sine fx, that is cos fx into f dash of x. And here fx replaced by this red color function. Fx is equals to under root sine root x. So we write here cos root of sine root x cos root of sine root x into ddx of in bracket here under root sine root x under root sine root x. Therefore, dy by dx is equals to cos under root sine root x into ddx of under root sine root x. So here we use the formula ddx of root fx 1 by 2 root fx into f dash of x, and fx replaced by this function, that is sine root x, green color function. ddx of under root sine root x. Use here formula ddx of under root fx 1 by 2 under root fx into f dash of x, and fx replaced by sine root x. So we write here 1 by 2 under root sine root x 2 under root sine root x into ddx of sine root x into ddx of sine root x into ddx of sine root x. Therefore, dy by dx is equals to cos of under root sine root x as it is. So we write here cos of under root sine root x as it is upon 2 into under root sine root x as it is into ddx of sine root x into ddx of sine root x. Use here formula ddx of sine fx cos fx into f dash of x and fx replaced by this root x. Fx replaced by fx replaced by this root x, that is the violet color function root x. So we write here ddx of sine root x, use here formula ddx of sine fx cos fx into f dash of x. So cos root x cos root x cos root x into ddx of root x into ddx of root x, this violet color function root x. dy by dx is equals to cos of under root sine root x cos of under root sine root x upon 2 sine root x into cos root x up to this as it is. So write this into ddx of root x, and this is the standard formula ddx of root x 1 by 2 root x. So right here 1 by 2 root x 1 by 2 root x, and this is the required derivative of the given function, and given function is, that is y is equals to sine under root x. Again, this can be written as here dy by dx is equals to here 1 by 2 into 1 by 2, 1 by 4. So right here 1 by 4. Then here cos under root sine root x cos under root sine root x into this cos root x into cos root x upon under root x upon under root x into under root sine root x and this is the required derivative of the function, that is sine under root x. So in this way we solve problem number 14 from exercise 1.1. So again, I request you, if you like my video, please subscribe my channel and press on bell icon. Okay, thanks.